given a vector space V, you can form the set of all linear functionals from V into K. And any toddler or really smart dog knows how to check that this is really a vector space itself. And we call this the dual vector space. Now this is all well and good, but the question is why? Why is it called a dual vector space? And why would someone do this specific construction? Because the first time I heard about this, I had no idea no idea why someone would do this. I had no idea why it was interesting. I thought it wasn't, and I had no idea how would someone think about doing this. Okay, so what I'm going to try and do today in this video for you is to offer some kind of explanation of this. It's not going to be a historical explanation, okay? I can't do that. It's going to be more like a conceptual explanation, or like some kind of trick that made me retrospectively understand better this stuff. Okay, and stems from changing your point of view on things. Okay? There are 2 points of view, well, there may be more, so let's say there are at least 2 points of views on mathematical objects. There is the one we all know and love, the elementary point of view, where we try to understand objects by their elements. That's why it's called elementary. Most of the time it's not really simple. It's just doing stuff by the elements. Okay. And if you stick to this point of view and you are stubborn and you really want to understand stuff only through this point of view, it's going to be really difficult to make sense of the dual construction. It's going to be especially difficult to understand how would someone think about this in the first place. Because you have some vectors and suddenly you're interested in the linear functionals from the space into K, and there's no really rhyme or reason besides some kind of inspiration from God or something, which may be the case, but I don't know. The way I really grasped the dual construction for the first time was when I shift my perspective and I try to see objects in the context of category theory. So there's the structural approach, let's say, where instead of trying to do as in the elementary way and trying to understand an object through its points or elements, which are vectors in this case. So instead of doing that, we try to understand an object by its relationships with other objects of the same kind. So we could say other objects in the same category, right? And here, of course, okay, we're working in the category of vector spaces and linear maps. So the key here is we're trying to understand what are vectors in this new context, new point of view, let's say. Well, I'm going to just tell you that you can see any particular vector is going to be identified with a specific linear map going from the base field into your vector space. Okay, so we're almost at the dual construction already. It's just the dual construction considers maps that go from the vector space into the base field, while now we are saying that vector spaces contain vectors and vectors are linear map from the base field. And most of you already know that the dual stuff, like duality, is very well understood and framed in terms of categories, right? So in a category you have morphisms and you have arrows, I should say, and then you can take the dual category where everything, like all the objects, they stay exactly the same. All the objects are the same, but the arrows, you just reverse them, and that gives you the dual construction. So we do that for the category of vector spaces and linear maps. So what happens? Well, we get a new category. Well, it's not really a new category per se, because everything's like, there's no new information, no loss of information either. You just reverse all the arrows. But now it's interesting because if we say that the vectors of a given vector space are arrows from the base field into V, well, we are in the dual category. So if we take some arrow like that, which I repeat is a vector, and then we look at what happens in the original category, which is the category of vector spaces with the arrows not reversed, well, we get a covector, which is a linear map from the vector space into the base field. Right, so we just reverse the arrows. And if we collect the set of all arrows from a specific vector space into the base field, well, that's a vector space, and we may as well call that the dual vector space, because we built it using the dual category. So yeah, I just thought this was interesting conceptually, I guess. There's probably stuff I'm missing here, and stuff that I didn't really unpack, and yeah, I would like to hear what you think about this. So until next time.